Okay, in problem number 14, that is from problem number 14 to 19, what we have to do is we have been given a geometric series and we have to find the sum of infinite number of terms of this series. So before I start doing this problem, I want you to understand how to calculate the infinite sum of a series. Now we know that the sum of a geometric progression is S is equal to A times 1 minus r to the power n, and it is divided by 1 minus r, right. So this is the general sum of n number of the terms, n number of geometric progression, right. So if there is a geometric progression, the sum of n terms is going to be a times 1 minus r to the power n divided by 1 minus r. Now what happens if your modulus of r, that is absolute value of r, is less than 1? For example, let us say r is equal to 1 by 2. Now you see that if r is equal to 1 by 2, r square is going to be 1 by 4, which is less than 1 by 2. R cube is going to be 1 by 8, which is still smaller, and R4 is going to be 1 by 16, and so on. So what we see is, as we increase n, we see that r to the power n is reducing. Now if n actually tends to infinity, that is if n becomes very very large, r to the power n will tend to become 0, correct. So in that case, what we can say is, if there are infinite number of terms in a geometric progression, but if the common ratio, if the absolute value of common ratio is less than 1, then sum can be given by a times 1 minus r to the power n will actually become 0 divided by 1 minus r, which is a divided by 1 minus r. So this is very important. Okay, the absolute value of the common ratio should be less than 1. If the absolute value of common ratio is greater than 1, then the sum will not converge, then the sum will either diverge towards positive infinity or negative infinity. Okay. Now let us do these problems. So what we know is, if the modulus of r is less than 1, then sum is a divided by 1 minus r, given that absolute value of r is less than 1. Now let us look at problem number 14. We can see that the first term a is 8 by 5. Now r in this case is, if you divide the third term by second term, is minus 5 by 8, right. Now what is the absolute value of r? It is 5 by 8. So modulus of r, or absolute value of r, is less than 1. So then we can use this formula, which is S, that is the sum of infinite number of terms of this series, is going to be 8 divided by 5 divided by 1 minus, and what is the r? R is negative 5 by 8. So negative 5 by 8, and you get 8 divided by 5 times 8. This is 1 plus 5 by 8, because negative will become positive. So this is 8 plus 5 is 13, right. Then you check 8 divided by 5 divided by 13 divided by 8. So this becomes 64 divided by 65. Okay, so this is problem number 14. Let us look at problem number 15. A is equal to 0.45, R is equal to 0.015 divided by 0.45. This is actually equal to 15 divided by 450. I have simply multiplied both the numerator and the denominator by 1000. So this becomes 1 divided by 30. And we see that R, or absolute value of R, is less than 1. So if we use the formula A divided by 1 by R, this is 0.45 divided by 1 minus 1 by 30 is 29 by 30. So times 30 divided by 29, and this is 4.5. So this is 13.5 divided by 29, or S is equal to 135 divided by 290. If you divide this by 5, you get 5 times 2 is 10, 27, and 5 times 5 is 27 by 58. 27 by 58 is I think we can leave this like this. Okay. Yeah. So this is 27 by 58. Problem number 16 is, we have A is equal to 1.665. Common ratio is, let me divide third term by the second term. So this becomes negative 0.74 divided by 1.11, or negative 74 by 111. This is 37 times 2. This is, let me check, 37 times 3 is 3 times 7 is 21. Yeah, so this is 2 by 3. So this is negative 2 by 3. Now you see that absolute value of R is going to be 2 by 3, and it is less than 1. So we can use this formula. Okay, so sum is going to be A, which is 1.665, divided by 1 minus R is negative 2 by 3, negative 2 by 3. So this becomes R, so this becomes 1 plus 2 by 3. So S is going to be 1.665 times 3, and this is 3 plus 2 is 5. Now we can cancel this. So 5 times 3 is 15, 3 is 15. So this is 0.999. Okay. Now let us quickly look at problem number 17. In this, A is equal to 3 to the power minus 1, R is equal to 3 to the power minus 2 divided by 3 to the power minus 1, which is also equal to 3 to the power minus 1. We can see that R is less than 1. So sum is going to be 3 to the power minus 1 divided by 1 minus 3 to the power minus 1. This is 1 by 3 divided by 1 minus 1 by 3 is 2 by 3, and you get half. Okay. Problem number 18. A is 3 for problem number 18. Okay, so problem number 18, a is equal to 3 and common ratio is 1 divided by square root 3, that is I am dividing the third term by the second term. Okay, so common ratio r is 1 divided by square root of 3. Now square root of 3 is 1.732 something, so we see that r is less than 1, so sum is going to be 3 divided by 1 minus 1 by square root of 3, and this is going to be 3 times square root of 3 divided by square root of 3 minus 1. Okay, if you want you can rationalize the denominator, just multiply 3 square root 3 by the conjugate of denominator, which is square root of 3 plus 1, that is if the denominator is square root 3 minus 1, we multiply with the conjugate, which is square root of 3 plus 1, so that we can get minus 1 square root of 3 plus 1. Now in the denominator we can use a minus b, a plus b is equal to a square minus b square formula, so sum is going to be 3 times square root 3 times square root 3 is equal to 9 plus 3 square root of 3 divided by 3 minus 1 is equal to 2. You can leave the solution at this stage also, this is also correct. I have just made the denominator free of any surd terms. Okay, so that is why I have rationalized the denominator. Now let us look at the last problem, which is problem number 19. The first term is 7, which is a is equal to 7. So a is equal to 7, r is equal to square root of 42 by 7, square root of 42 by 7. Now we know that 7 square is 49, so square root of 42 is definitely less than 7, so r is going to be less than 1. So we can use the formula for infinite series. Anyway, let us simplify this further. So square root of 42 can be written as square root of 7 times square root of 6 divided by 7, which is equal to square root of 6 by 7. So sum is going to be 7 divided by 1 minus square root of 6 by 7, and this is equal to 7 times square root of 7 divided by square root of 7 minus square root of 6. Now you can leave your answer at this stage, but if you want to rationalize the denominator, you have to multiply the numerator with the conjugate of the denominator, which is square root of 7 plus square root of 6, and in that case your denominator will become square root 7 square, which is 7, minus square root of 6 square, which is 6. 7 minus 6 is going to be 1, and finally your answer is going to be 7 times square root of 7. 7 is 7 square, so 49 plus 7 square root of 42. Okay, and we are done.